And now, without further ado, let's introduce our speaker. Kitty Young is a physicist, engineer, artist, fashion designer, maker, and musician. Hopefully that's already captured your attention. She currently works as senior quantum architect at Microsoft Quantum Systems. She's the producer of Microsoft's quantum learning materials, including the MS Learn quantum modules and the quantum learning website. Author of comic series, Quantum Computing and Some Physics, lecturer at Hackaday University and Microsoft Reactor on quantum computing. To drive integration between science and art, she also founded a sustainable and STEAM fashion brand, Art by Physicist, and leads the fashion hack at Microsoft. Prior to that, Kitty worked as a manager and creative technologist of the Bay Area Microsoft Garage program. She was a UX designer at Intel Maker Group, research scientist and hardware engineer at Intel Silicon Photonics, PhD in applied physics from Harvard, an MSc and BA in natural sciences from University of Cambridge. She is socially very active. You can connect to her. And let's hand it over now to Kitty.
Hi, everyone. Thank you so much for having me. Let me just start sharing. I would love to hear or see what are the background of the audience here. So feel free to introduce yourself if you like. And I would love to also know a bit more of what do you work on and your level, your stage in your career right now. Because this talk is also about quite a few things, showing my work as well as talking about the career track. So I'd love to also learn from you too. Can you see my screen?
Yes, we can. Yeah, you are good.
Okay, good. Yeah, I'm trying to also open Zoom so that I can see the audience. All right. Thank you so much for having me, and thank you for joining us on a Friday. I am Kitty, as Yurika introduced. Thank you so much for organizing, and Nasni. So I am a senior quantum architect currently working at Microsoft. This is my current day job, but as you saw that I have quite a few different gigs going on. And I will be showing you some of the work that I have been doing for my everyday job, as well as things that I've been doing on the side. So quantum computing basically hinges on my background in physics. Guess what? I actually get to also draw a lot of pictures. What does the quantum architect entail? I would have not thought that I would be using my artistic and creative skills in this job, but it's super, super fun and exciting that actually drawing and communication is extremely important in emerging fields such as quantum. So my day job actually involves me drawing a lot of diagrams, explaining things, actually explaining physics. That's why we need the drawings. But what I'm showing you here are things that I publish externally, because I can't really show you my internal documents. But you get an idea of basically, we need to communicate, and there's so many different types of people working in this industry, and they all have different backgrounds. How does a software engineer understand how hardware engineers work? How do marketing and design team and program managers understand the technical areas? So there's a lot of collaboration. And as architects, I'm helping the team to bring many of our team members together and carry on this quantum journey. So I will show a little bit more of the things that I produced at the quantum team later. Just a little bit of the background. This is basically my career track. It seems to be two parallel tracks. One is the physics and the technical engineering. The other is art and music design. So for a lot of people, those seem to be two separate things, but then they are constantly inspiring myself and constantly crossing each other in my work and life. Essentially, what I do is a spectrum from science to engineering to design and art. As a lot of people may think that science and art are two extremes. They are very different, but in fact, they're very, very similar. They're both exploring the unknowns, and they are pushing the understanding and the boundary of human knowledge. And those inspiring fields then help engineering and design these more practical fields to learn from these more exploratory fields. And at the very interface between engineering and design, that's where we make things that people would need and love. So starting my professional career, that was back in University of Cambridge. I'm a physicist and I specialized in condensed matter physics. And I don't know how many of you in the audience have similar experience. I used to work with cold temperature and high pressure, basically pushing the boundary of the materials property to the quantum regime and to study the quantum properties of materials. So I got to work with dilution refrigerator and went to the machine shop to build all these equipment that we were using in the lab. Because it was so cutting edge, there were things that we couldn't really buy off the shelf, so we actually had to make them by hand. So even back then, I felt I was actually already a maker, but I didn't realize it until later. Now I wanted to do more applied things. In undergrad, I was doing a lot of fundamental research, but I also knew that I want to apply the knowledge I learned in building devices to benefit more people. That's why I went to Harvard to do my PhD. And there I created circuit structures using plasmonic effects. So plasmons are seas, ocean of electrons, and the electron collective interaction will create waves in the sea of electron. And in 2 dimensions, you have very special properties of electron waves, plasmonic waves. And that's what we utilize in our lab to create miniaturized electronics. So I got to go to the clean room and simulated my own structures. So you can see there are some micron size and 2D electron gas and graphene structures that I was making. So design those things, simulated, theoretically prove them, and then went to the clean room and hands-on fabricated them. That was a really interesting experience, especially coming up with something from scratch and deriving that from the beginning to the end. Because my PhD study was highly related to photonics, that's when I graduated, I went to Intel to do silicon photonics. And that's also when I met a lot of the people in the audience here from Women in Photonics group. That was a very rewarding feeling when you invent something in the lab, but then having the ability to scale it into real products and applications that millions of people could benefit in the world. So in industry, I really learned how scaling works, something that I wouldn't have learned if I stay in academia, just building something small, intellectual in the lab by hand. So in industry, it was a really good feeling, especially also when all the engineers and the team are collaborating together towards the same goal. So many people investing their energy and time into the same goal to drive good impact on the society. During that time, I stumbled upon something super interesting, which was open source hardware. And you may ask, Utica, this might be the thing that attracted me away from silicon photonics. But that was a very interesting time when open source hardware was on the rise. And I don't know, feel free to let me know in the chat. I'm trying to also watch it as I talk. If you are familiar with open source hardware, things like Arduino or Adafruit boards, which you can program very easily and build your own systems. You can connect these boards. They're like microcontrollers and single board computers that are small, and you can connect to all kinds of sensors to build your own projects. Intel was making boards using our own chips. So then I got moved to that team, became a user experience designer for these kind of open source hardware. So it was a nice detour, but it really integrated with my side artistic interests. So I was using these boards to build fashion. Fashion has been a side hobby that I started when I was finishing my PhD. But then I just got more and more into it as I became more and more technical with fashion. So you think, how is fashion related to technology? So for example, I was embedding all kinds of hardware and electronics into clothing. This dress actually, it has a board that is Wi-Fi enabled that connects to the headset I was wearing. So it detects my EEG brain signal, and you can program the intensity of the thought to map to the colors and patterns on the dress. Interesting demonstration of this technology. And then I did something also, a lot of the projects similar to that. This is using machine learning, is actually using Intel's Arduino 101. It has pattern matching engine, accelerometer, Bluetooth, many different types of components on the board. So I was holding it in my hand, it's connected to the dress, which has 4 constellations configured using LEDs. You can train this board to memorize your gesture. Every time you move your hand in the right way, then it would trigger the constellation to be called up on the dress. And this fabric is also the one page from my graphic novel. A scientist and her robot looking into the telescope. As you wave your hand in the right way, it causes the constellation to show up. So I have programmed these 4 commonly seen astronomy signs, and that at the same time demonstrated for our customers how Intel Arduino 101 worked. So Intel Curie was the chip. Then it was all fun building these demos until, well, it's still fun, but you start to find problems in the industry when people are starting to ask you to make more, like to produce for them. So when I was at Intel, we had this participation in Maker Faire. Every year we had a big booth, and there are a lot of volunteers from the company introducing visitors about our products. I was asked to design a t-shirt for the volunteers and to demonstrate our technologies. I came up with this idea that has wearable robots, that has the Intel Curie on a tiny tile chip, and then it's connected to distance sensor and some displays and also microphone. And then it's attached to this conductive traces on the t-shirt. As you rotate the robot, it will connect to different traces and light up these products and the potential applications. It detects the angle, so it will also know which one is attaching to and show the product image on the screen. So this would be a super cool project to demonstrate. It also shows the hello message as a visitor approaches you, it detects distance and it would display certain messages. If we were able to create this, it would be such a nice project. But then we got into the problem that there was no one who was able to even manufacture it. Turned out that the robot is really easy to use, but then no one was able to fabricate or manufacture the conductive traces on fabric. The soft circuit turned out to be much more difficult to make than the hard circuits. So that was an interesting learning for me, and it really triggered my curiosity. But then around the same time, Intel decided to cut the products. Nothing to do with the conductive traces. It's just company decision, and they discontinued these products, which was very sad. But then I thought, okay, so I can't do this for my company, but there's no one stopping me from still pursuing my interests and hobby. So I actually started a company called Art by Physicist. No one can stop me from pursuing my passion. So I started this fashion brand specifically to look into the technical problems that wasn't allowing us to manufacture those interesting handmade projects. There are a lot of makers, a lot of great ideas around. We can build things by hand, one by one, but then how do we scale those? So I continue building those ideas, even though I couldn't do it for my day job anymore. But then I didn't stop pursuing my passion. I continue to make projects like these. This one is showing a heart rate monitor dress. The LEDs would blink according to the heart rate. You can see the peak of my heart rate on the computer here. Of course, not everyone wants to show their heart rate to the public, but what I wanted to demonstrate there was we don't have to limit our imagination to just medical devices or sportswear. How about embedding technologies, hardware into anything we want to wear? Beautiful dresses, everyday wear. There's a lot to explore. I made these projects open source because I learned so much from the open source community. I also build my projects open. So if you go on to Hackster.io or Hackaday.io Instructables, you may find some of my projects there. But more importantly, you will find all kinds of creative projects from makers around the world. So this is one of the ways I'm contributing back to the community by also making my projects open. Later on, I did develop some of the project into products, which I will show you later. But I think the open source is super important for democratizing technology and getting the community to pursue their passion. So while I was doing this, my work was discovered by my then manager at Microsoft. The Garage is a very interesting program at Microsoft. I would love to hear where you're working from. I don't know if your company has anything equivalent to this, but at Microsoft, we have this program that encourages any employees to pursue their ideas. The Garage is a platform for innovation. I was hired to be the manager for the Bay Area Garage, where I could support my colleagues to do something similar, to build teams and pursue their interests, projects, and also run hackathon, helping the ideas come into reality. Is kind of a really not just incubation, but also getting people's hand dirty and hack together and build something. No matter where you are in the organization, you can collaborate. That was a very interesting experience, especially to support the company and the colleagues to do something similar to what I was pursuing. During that time, I also found that a lot of people were interested in quantum computing. So I was interested myself. As you saw, I'm a physics PhD, but it didn't mean that I actually knew anything about quantum computing. I was interested in it, so I started learning it. And I was able to learn it very fast because of the physics background. So if physicists in the room, if you are in a different field, you may want to look into quantum and also find it very intellectually interesting. And then I noticed a lot of my colleagues were interested in it, but they're in a different field in engineering. They didn't quite know where to start. Then I thought, why don't I just start teaching people? So in the garage, you can really do all sorts of things. Actually, a lot of the garage projects could even turn into company actual businesses. The garage also shipped products out. So that's a very interesting mechanism. So we were able to form all these study groups in the garage. And I started teaching my colleagues how to learn quantum computing. And Q# is the programming language that Microsoft invented. So I started teaching them. The other thing that I noticed about quantum computing is that you don't even have to have a PhD in physics or math to start learning. So that is super encouraging, because anyone could really just sit down and walk through the logic and be able to grasp it. And I think that's also a good thing about quantum being open source, and the software development is really democratized. So my work then was noticed by the quantum team. Then I was hired to do this full time. Last year, I launched this learning program, the MS Learn modules. You can check out this link here. Is a set of education materials that's hands-on tutorial, teaching you to go step by step from getting started with the hello world of quantum, like doing a random number generator with a qubit, gradually leading you towards running your algorithms on the cloud. We have Azure Quantum, that is our product on the cloud, hosting all kinds of quantum hardware. So I was really lucky to be joining the quantum team, and also again pursuing something that I was doing on the side. And I also noticed that many people are coming from different backgrounds. So we really need to provide them the learning materials that are suitable for their different backgrounds. So then I got to use my user research experience building a learning site that offers different kinds of materials, and based on people's interests, goals, and their levels in like quantum mechanics or linear algebra. So this was another product that I launched. And then on the side, I kept on pursuing my other interests. So I is still connected to quantum. Every Sunday, I was publishing 2 pages of comics. I wanted to explain to the general public how quantum computing works, to the external communities. I noticed that quantum in the past few years had a lot of hype, as you probably all noticed. And there's a lot of misconception in this field. So we really should give people the right information, at the same time not change the fact, not simplify to the point that is not real physics anymore. So I use my drawings to explain those ideas. Interestingly, I was publishing this, and then I got to teach at Hackaday. I mentioned Hackaday is also an open source platform. So every Sunday I was teaching a group of enthusiasts from all over the world learning quantum. And I did that from March last year to November. Turned out that I accumulated enough teaching materials. I was able to publish a book. So I had all these drawings then accumulated into a book, and I made it into a nice booklet of comics with places you can write notes on. So that was a wonderful side project that I didn't even think I was going to do that. But just by doing something I was interested in, it all came together. And it was discovered by some editor at Forbes, and they even used it in an article about Microsoft quantum computing. So that was a nice surprise. But when I put my work out there, it gets noticed. So you should do that too. If you have some passion, you have things that you want to pursue, just go for it. And sometimes your goal is not to get rewarded, but sometimes surprising things happen. So what I learned so far was that I can really create my own future. I think sometimes people are afraid of doing something that their boss didn't tell them to do. But there are many ways you can contribute to the society, to your work, to your life. And what I really learned was that even if my day job did not allow me to do some things, I could still do it. No one can stop me from doing that. And that's also when I realized how important it is to balance these different areas. How many of you know about this concept called Ikigai? It's meaning of life in a Japanese concept. A meaning of a reason for being. So it tells you a very optimal state in your career or life if you can align what you love, what you can be paid for. Of course, you have to be practical, and what the world needs and what you're good at. If you can map the four together, you can get to this optimal state that you feel really happy and fulfilled. When there were times that I wasn't able to do what I love, and I really experienced that. So I knew that I needed to shift upwards. I was there before. Something like I'm comfortable, a feeling of emptiness if you're doing something you don't truly love. So you can take a look at this map and see where you are. If there's anything that offsets you from Ikigai, then you may want to try to shift in that direction. Also, of course, it's very important to know what the world needs. It's probably easy to figure out these other three regions, but what does the world need? There are also some guides. I like to use this 17 goals, the global goals where we need the most effort around the world. It's not necessarily just engineering, but many social problems, environmental problems, political problems. There are many things, many ways we can contribute to the society. My day job allows me to target some of them, but I also can see that my side projects also targets additional goals. Even if you just find one thing that you're truly passionate about and you really pursue that, is a great way to go. Okay, now I'm going to tell you something about the side projects that I was pursuing purely based on what I love, but then somehow it led me into what the world needs. Going back to the company that I founded, the tech fashion brand, the focus of this brand is also to democratize technology, to use open source ideas into fashion. I think fashion industry has been running a bit separate from the engineering field. They haven't picked up some of the more advanced ideas and technologies, but we could really use similar ideas in fashion and help them in a very big way. Just to start with, I can show you some examples of the projects and the product that we built that is very different from traditional fashion. For example, I mentioned that it was super hard, that was 2017, to build soft circuits. So in the past few years, I was exploring the technologies available that could be applied to fashion. And through the company, I was able to collaborate with some of the industry leaders in printed electronics and wearable flexible electronics. So I will build this shirt, for example, is displaying constellations using printed electronics. This was a project I did with a American company called Novacentrics. We were able to create these 12 constellations corresponding to, you see, I love astronomy. So this is a design that shows using flexible circuits in fashion. And is all productized now. It's no longer at the point that we can't even produce them, but now we can scale. On the right here is a design using a big flexible LED panel that can display images, videos, anything that you want. You draw on your phone and then send it through Wi-Fi to this dress. Some more examples. On the left here, these two are flexible solar panels that are laminated onto fabrics. It works really well on all kinds of fabrics and is a thin film technology. I work with the company in Germany called Amor. They focus on thin film technology. We were able to put this on all kinds of designs that's nicely created. And this is lotus shape. I don't know if you can see from my video here. I also have this lotus design at the back of my background. You can charge your phone through a USB charger. It's a solar panel, so you can harness solar energy from your clothes. On the right here, this is a flexible heater and also very, very thin, and you can fold it, you can adhere it onto fabrics, and you can make beautiful coats with the heater inside it. And then, yeah, this is a long video. And this is also reversible. On both sides, have my paintings on the fabrics. And then this is a accessory. It's a pair of Bluetooth connected brooches that's programmed to sync with each other. You can wear this with your family and your friends and imagine all the interactions you can create. So in this case, I had it set to allow you to detect distance. So a mother and her child could wear this. If the child runs off, the mother can get a notification. Her flower would vibrate. There's no connectivity needed on the phone. The mother can feel it immediately, and the mother could start looking for the child. This is also a collaboration with an open source company called DF Robot in China. We're able to bring this from my handmade soft flower into this PCB board that has these LED on it and accelerometer, touch sensor, Bluetooth, all these different components on it. So you can actually use it to program for the applications you like, and the two can pair with each other. There's so many possibilities you can imagine. Very, very nicely, this year we ran a Kickstarter, which was successful. So we have been shipping all these products that I showed you. That was a really interesting and good learning experience, running a Kickstarter, getting the orders in advance, and then fulfilling them based on the orders, which is more environmental friendly because we don't overproduce. So that gets into the next topic, fashion industry. Through my experience, I learned a lot of pain points, very bad things in the fashion industry. One being not environmentally friendly. And also we haven't seen a lot of the fashion brands that's inspired by STEAM or contributing back to STEAM. That's exactly what my brand is doing. with the Kickstarter and the sales, we donate to STEAM education and environmental protection. Why do we do this? Because as I explore in this industry, I found these sad facts about fashion. Is one of the largest industry in the world, $3 trillion market, but it also is one of the most polluting industries in the world. Every year, it generates 10% of carbon footprint globally. 30% of clothes ever produced are never sold. What do? The brands try to get rid of their inventory. If they don't sell, they just send them to landfill or burn them. So it generates huge amount of pollution and waste. But the industry knows about this problem. Every year they will publish things about sustainability. We need to do something about it, but we haven't seen substantial solution to solve the problem. And COVID really hit it hard. COVID disrupted supply chain and disrupted retail. It really hurt the industry, but we also saw that the environment improved because there was less production. And how about we just don't make anything until someone needs it? There must be technologies that can help us solve all these problems in the industry. Because of my background in science technology, I couldn't help but wondering, can we use some of the technological methods that we use to produce chips, design PCBs? Can we use similar ideas in fashion production? Turned out we could do that. There are now software that can allow us to do realistic simulations of fabrics. You can see this is my handmade design of a satin dress. As you rotate, you see the satin ring, but it also has a digital twin. So the pattern of this dress is open source, which means the pattern is directly printed on the fabric with the painting. So people can actually buy this fabric and do cut and sew themselves. But also it's got a digital twin. So whenever people orders, it could be produced. So my brand is building all these digital assets of the fashion designs. So we reduce the sample waste and no overproduction of the products. And we could also use technologies to do made-to-order mass customization. I've stressed that made-to-order is important for reducing overproduction, but also mass customization used to sound like two conflicting ideas. You can either be customizing bespoke or mass production. But now with technology, we can do both. And what does that mean? That means people would be able to visualize and experience a design before they are even made. So customization means two things, the look and the fit. We can allow consumers to directly tell retailers, designers, manufacturers what they really want. They can even upload photos of clothes that they like and do modifications of it and get it made just for them. And the fit would be also made just for them. We, as consumers, all know our body shapes are different, and we can modify designs digitally to fit different body types, body shapes. There's not really a standard sizing. Everyone's shape's different. What the industry really needs is a complete ecosystem. It needs to support creative designers to bring their vision to life faster and easily, and also be able to provide capabilities to allow consumers to let the producers know what they want before they're even made. And it also requires democratized manufacturing, distributed local distribution that are fast and support small businesses. And this is now a project that I've been driving at Microsoft to solve the industry problems that's been going on in the fashion world, to use all kinds of technologies to help the industry to go to a truly sustainable model. I would end my talk very soon by raising a question. So as I explore this journey from bringing creativity to productivity, I often trap myself in this philosophical question is, what's the meaning of production? So we are building all kinds of technologies, hopefully to relieve us from doing repetitive work so that we can do more creative work, get all these boring things done using robots and algorithms. But then eventually we may realize that what's the meaning of doing creative work? Because nature has already been building art much better than humans before we even existed. There must be an answer to that. And I think I'm still on the pursuit of the answer. But the one thing that's clear is that technology is to empower people, not to replace people. But what about a world that looks like this? Do you think this is really supporting people, empowering people, or isolating people? We've been talking about metaverse. A lot of the fashion applications, technologies will use metaverse technologies, but there's a connection with the physical world. Do we want to live in a world that's purely virtual? What will happen to our physical bodies? So I think each one of us in technology has the power to control that and define our own world, own future. And I think a lot of the problems in the society is caused by silos, disconnectivity between different fields. The problems that I discovered in fashion was caused by fashion industry not using some of the latest technologies. People are not understanding each other. Problems that we have in quantum is also people don't know how to use it right now. But if we connect all of these things, we can move in a very positive direction. And eventually it is happiness that we pursue, and it is because of happiness we create that can drive our society to move in a positive direction. So if you don't like the words technology other people build, you have the power to change it. Thank you.
Thanks, Kitty. That was definitely a powerful thought. I'm literally getting goosebumps there. But